In these caves, which Mayan lore describes as a fantastical underworld, methane and the bacteria that feed off it form a vital part of an ecosystem that is similar to what's been found in deep ocean cold seeps and some lakes. Between 2013 and 2016, 5 field campaigns were conducted to investigate cave networks through Cenote Bang, the primary study site within the Oxbow-Ha cave system, and secondary locations. The researchers collected water samples as well as shrimp samples in the caves. A. Entrance pool of Cenote Bang. B. Subsurface vantage of Cenote Bang entrance pool, the primary locations where particulate organic detritus enters the system without being filtered. The researchers, who are trained in cave diving in addition to their other expertise, had to use techniques that had previously been used by deep-sea submergence vehicles to be able to study the environment. Finding that methane and other forms of mostly invisible dissolved organic matter are the foundation of the food web in these caves explains why cave-adapted animals are able to thrive in the water column in a habitat without visible evidence of food. This subterranean estuary complex covers an area about the size of Galveston Bay, the 7th largest surface estuary in the U.S. The freshwater portion of the caves and the sinkholes, which are used to access the caves and are referred to locally as cenotes, are important sources of freshwater for communities throughout the Yucatan. The microbes eat both the methane in the water and other dissolved organic material that the freshwater brings with it from the surface. The processes we are investigating in these stratified groundwater systems are analogous to what is happening in the global ocean, especially in oxygen minimum zones, where deoxygenation is a growing concern, says John Pullman, a co-author of the study and a USGS biogeochemist whose work from the early 90s motivated the research. Although accessing these systems requires specialized training and strict adherence to cave diving safety protocols, relative to the complexity of an oceanographic expedition, the field programs we organize are simple and economical. Previous studies had assumed that the majority of organic material that feeds the microbes of caves came from vegetation and other detritus, debris, in tropical forests that washed into the caves from the cenotes.